Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626. Unit 2 Electric Heating and Welding System. Design of resistance heating element. In this, we will see how the design of resistance heating element is done. When the heating element reaches steady state temperature, all electrical input is given out as heat. According to the Stephen's law, the heat radiated to the charge is given by H equal to 5.72 K into E bracket T1 divided by 100 raised to 4 minus T2 divided by 100 raised to 4. Unit is watt per meter square, where T1 equal to temperature of the source in degrees Celsius absolute, T2 equal to temperature object absorbing the heat in degrees Celsius absolute, K equal to constant called radiating efficiency, 1 for single element and 0.5 to 0.8 for several elements. E equal to emissivity, 1 for black body and 0.9 for resistance heating element. Degree Celsius ABS equal to degree Celsius plus 273. Let V be the applied voltage to the heating element in volt. R equal to resistance of the heating element in ohm. R equals to rho L by A. If the circular conductor is used as A equal to pi d square by 4, where d is the diameter of a circular conductor, L equal to length of the conductor, rho equal to resistivity of a conductor material. So R equals to rho L by A. In this formula, we have to substitute the value of A, which we have considered a circular conductor. So in the place of A, we have to place the value A equal to pi d square divided by 4. Now, we will rearrange this equation and we will get R equal to 4 rho L divided by pi d square. Now, we know P equal to V square by R. So, now substitute the value of R in this equation. So, we will get P equal to V square divided by 4 rho L divided by pi d square. Now again rearrange this equation and we will get P equal to pi d square V square divided by 4 rho L. Again we have to arrange the equation in form of L divided by d square. So we will get L by d square equal to pi V square 4 rho P. So here is the circular conductor, its diameter, and here is the rectangular conductor which is having the length and width equal to pi d. Now surface area S equal to pi dl and heat dissipated per unit area equal to H. So therefore total heat dissipated equal to pi dl into H at steady state temperature Power input equal to total heat dissipated. So the power formula pi dl into H. So we have to substitute the power formula and we have to rearrange the equation in the form of d square by L. Now we get pi dl H into 4 rho divided by pi v square. By cancelling the pi value in numerator and denominator, and by cancelling the d square value by the right hand side d, so we get t by L square equal to 4 rho L divided by v square. Now solving the two equations, we get the length and diameter of the wire are formed. If flat rectangular cross section conductor of width W and thickness T is used, so area equal to width into thickness. We know the power equal to V by R square. Then again substituting the value of R, that is rho LA, in this equation. So here now we have to put the A value is W into T for the rectangular cross section area. So we get a final formula as a L divided by W into T equal to V square by rho by P. At steady state temperature, power input equal to heat dissipated. So power equal to 2 WLH, neglecting the side area 2TL because thickness is too small. So power equal to V square W into T divided by rho L equal to 2 omega LH. So now T divided by L square equal to 2H rho divided by V square. So solving equation, we can found L, T and W is found. So here we have taken the example for how to design the heating element for a circular and a rectangular heating element. So by using this formula, we can simply find the heating element design. Now the next heating is the arc heating. So the heat energy of electric arc, it is utilized for heating. So the working principle of arc heating is an arc is made to struck between two electrodes by applying breakdown voltage across them. The arc is struck and the current flows from one electrode to other in the form of the arc. The voltage required to struck the arc is much more as compared to the voltage required to maintain the arc. The arc has negative volt ampere characteristics. So one arc is struck, heat energy is radiated. The charge to be heated is kept in the vicinity of the arc. The heat of the arc is passed on to the charge and therefore the charge is heated up. Now the type of electrode used for the arc furnace are self-baking, carbon and graphite. So the self-baking electrodes, these are used in ferroalloy and in production of aluminium. A paste is prepared as per the process is filled into a steel casting. When current passes through the electrode, heat is produced. Then the second is the carbon electrode. These are made of anthracite coal and coke. Pitch is used as a binder material. The mass consumption of carbon electrode is 20 kg per 100 kWh for steel furnace. Graphite rod, the carbon electrodes are baked and cooled. The annealing process is carried out at 220 degrees Celsius to form graphite electrode. The mass consumption is 7 kg per 100 kilowatt hour. So the properties of the material used for electrode are: it should be good electrical conductivity, infusibility, chemical internals, insolubility, good mechanical strength, resistance to the thermal shock. Now the advantages of graphite electrode over the carbon electrode are: resistance to the thermal shock, hence can effectively withstand the temperature stresses. Low coefficient of thermal expansion. It is available in large blocks and the weight is less and the electrical conductivity is better and the high temperature strength. So here are the advantages of graphite electrode over the carbon electrode. Now let us see the comparison between carbon and graphite electrode. So the first point is the carbon, these are the amorphous, and in the graphite it is obtained by heating carbon electrodes at high temperature, so the graphite is obtained. Next thing is, for small size, current carrying capacity is less because specific resistance is more, and for the graphite, for the same size, current carrying capacity is more because specific resistance is less. So it is 1/4 as that of the carbon. Carbon, it is a cheap, and graphite, it is costly because it is obviously obtained from the carbon electrodes at a high temperature. So as compared to the carbon, it is graphite, it is costly. So you can see the double of the carbon electrode, the cost of the graphite is there. And the other point is used for the small capacity furnace. So the carbon are used for the small capacity furnace, where the graphite is used for the large capacity furnace. So basically the graphite is having the advantages over the carbon, as we have seen in a previous slide. So therefore it is having a much greater qualities as compared to the carbon. But here is a disadvantage, like it is costly because it is almost about to double of the carbon electrodes. And for the same size, the advantages is the current carrying capacity is more because it is specific resistance is less. So obviously resistance and current are inversely proportional to each other. Therefore, for having the maximum current to flow, the resistance should be low. Then we have seen the construction of it and the large, and this graphite electrode are used for the large capacity furnace where the large mass production is there. So in this video we have seen the comparison of the carbon electrode and the graphite electrode. Then we have also seen the advantages of graphite electrode over the carbon electrode, that it is weight is less, then high temperature strength and electric conductivity is better, then resistance to thermal shock, and hence can be effectively when the temperature is stresses. And we have also covered in this slide that the properties of the materials used for electrode, what are the properties that should be in the electrode. Then we have also seen the types of electrode, that is carbon, graphite and the self-baking. And we have seen the arc heating, that is what is the working principle of arc heating, and we will discuss in our next video that what are the types of the arc heating. Thank you.